Hello, this is Mr. Anksman, and this is the first part of the notes from section 10.3. On 10.3 is on percent composition and chemical formulas, and today's notes is just going to be on percent composition. But the learning goals for this section are to calculate the percent by mass of an element in a compound, and that's the one that we're going to do today. And then it's also to calculate the empirical formula and molecular formula of a compound and distinguish between empirical and molecular formulas. You'll be doing those two the next couple of days with the other sets of notes. Okay, so percent composition is defined as the percent by mass of elements in a compound. So one thing to know is that percent composition is always the same for the same compound no matter how much you have. As in, if you have like a glass of water, it's going to be 89% oxygen by mass, or if you have like a swimming pool of water, it's still going to be 89% oxygen. So those percentages will stay the same no matter how much of that material you have. And then there's two different ways that we can do these calculations, and we're going to practice with both, but we want to be able to use mass data or molar masses from our periodic table to be able to figure out percent composition. But in general, you have this equation down here. Percent by mass of an element is going to be equal to the mass of an element divided by the mass of the compound times 100. Okay, so here's the first type. So the first type of problem is figuring out the percent composition using mass data. So with this type of problem, we don't need the molar masses from the periodic table. We just use the information that's given in the problem. So for this example, we say, what is the percent composition of the compound form when 2.70 grams of aluminum combines with oxygen to form 5.10 grams of aluminum oxide? So we want to find percent composition. What that means is we want to find the percentage of each element that's in that compound. So in this case, we have two. We have aluminum and we have oxygen, and we want to figure out a percentage of each. Okay. All right, so I switched over to this Jamboard to show the work. So we want to find the percentage of each of the elements, aluminum and oxygen. Okay, now in general, the percent composition for each of these elements, it's going to be the mass of the element. I'm just going to use E to represent element, divided by the mass of the compound. And we'll use C for compound. And then we divide that out and multiply by 100. Okay? And we want to find a percentage for aluminum, and we want to find a percentage for oxygen. Okay? So in the problem, it says we have 2.70 grams of aluminum. So we're going to take that mass, the mass of just the aluminum, divide by the mass of the compound. So it says we have 5.10 grams of aluminum oxide. And then once we divide that out, we're going to multiply that by 100 to get a percentage. And then this ends up being 52.9%. Right. Now the rest of the mass in that compound is from oxygen, and the percentages need to add up to 100. So you could just subtract from 100 to find the percentage of oxygen, but let's do the calculation here too, just a similar type calculation. Now it doesn't say the mass of the oxygen, but we know the mass of the compound is 5.1, and we know the aluminum part is 2.7. So the mass of the oxygen has to be the difference. So 5.1 minus 2.7 is going to be 2.40 grams. So we just subtract to find the mass for the oxygen. So then we take that divided by the total mass of the compound again. Multiply that by 100. and we end up with 47.1% after we round it off to 3 significant figures. Okay, so that's the percentage of oxygen. Here's a percentage of aluminum. Now when we add those two together, we will get 100%. Okay, now let me okay, now we switch back here. Now here's another sample problem for you to try out. Okay, so in this one we have a 13.60 gram sample of a compound containing only magnesium and oxygen. It's decomposed. 5.40 grams of oxygen is obtained. What is the percent composition of this compound? All right, so with this one, find the percentage of magnesium and find the percentage of oxygen. So do that calculation. You can pause the video, and I'll show you the answer in just a bit. Okay, so here's the calculation for that. So for magnesium, we take the mass of the element divided by the mass of the compound. Now the mass of magnesium, we had to subtract the total mass of the compound minus oxygen. So to get 8.20 grams of magnesium. So divide that out, multiply by 100, we get 60.3% magnesium. For oxygen, similar calculation, we were given the 5.40 grams of oxygen. Divide that by the mass of the compound that was given. Multiply by 100, you get 39.7%. Okay, so that's finding percent composition using mass data. Okay, now the next type of problem is percent composition from the chemical formula. Now with this, we need to use molar masses from the periodic table. So let me exit out of here and okay, so I exited out of the slideshow for the Jamboard so I could show the work. Okay, so we want to find the percent composition of magnesium fluoride. So that means we want to find a percentage for magnesium and you want a percentage of fluoride. So all we're given though is the chemical formula for this compound. Right, now with this we want to use molar masses. So then in general it's going to be the element divided by the compound, but the way you do it here when you just have the chemical formula is you're going to take the mass of the element in 1 mole divided by the molar mass of the compound, and then we're going to multiply that by 100 to get a percentage. All right. Now molar mass is from the periodic table, so magnesium has a molar mass of 24.3. And then fluorine has a mass of, that rounds off to 19.0. But then since there's 2 fluorines in the compound, 2 fluoride ions, we're going to multiply that by 2. So 19 times 2, that's going to be 38. Okay. So the mass of the element in 1 mole for magnesium, it's going to be 24.3. For fluorine, it's going to be 38.0 grams per mole. Now the molar mass of the compound is just going to be the sum of those two. So it's going to be 24.3 plus 38. So that's going to be 62.3. So for magnesium, we're just going to divide by that 62.3 grams per mole. Sorry, that's kind of sloppy there, but then you multiply that by 100. So 24.3 divided by 62.3. Then we multiply that by 100. It's going to be 39.0% magnesium. Again, these two need to add up to 100, but for fluorine, it's going to be 38 divided by the molar mass of the compound, 62.3 grams per mole, multiplied by 100, and we get after rounding off, it ends up being 61.0% for the fluorine. And 39 plus 61, that adds up to 100%, which is what we're looking for. Okay, so it's 39% magnesium, 61% fluorine. And again, all these numbers came from the molar masses on the periodic table. Okay, switching back over to the slideshow now, so we showed that problem. Try this one out. So we have propane, C3H8, the fuel commonly used in gas grills. It's one of the compounds obtained from petroleum. Calculate the percent composition of propane. All right, so we want to find a percentage of carbon and a percentage of hydrogen. So try that one out, and I'll show the answer in just a second. You can pause the video. Okay, here's the answer for that. And again, for each of these elements, it's going to be the mass of that element in 1 mole of the compound divided by the molar mass of the compound. So for carbon, since we have 3 carbons in C3H8, it's going to be 3 times 12. That's where this 36 comes from. 44 is the molar mass of the entire compound, C3H8. Multiply by 100, you get 81.8% carbon. For hydrogen, we have 8 hydrogens. Each one has a molar mass of 1. So 8 divided by the total molar mass times 100, you get 18% hydrogen. All right. And that's all for the notes for this first part of section 10.3. Have a great day.